Um, I'd like to turn over to Diane Brandley, president of the Greening USA Board of Directors, to tell you a little bit about Greening USA.
So Greening USA is a 501c3 New York corporation, educational nonprofit. None of us receives a penny for what we do. So this organization operates strictly with volunteers, and we pay for our Zoom and other minor expenses with membership dues. So if you believe that we do something of value for the Central New York community, I urge you to become a member. And if you feel like this is an organization that really speaks to your heart and things that you believe in, then we urge you to get involved and become a member of a committee and even a board member. We do have board member vacancies. So thank you for being here today.
Thanks, Diane. And I'll just say a couple of housekeeping things. Please keep your microphone muted unless you're called upon to speak. We have about 50 to 55 minutes presentation for you today, and we expect that we will have time, about 30 minutes following that, for hopefully a very exciting question and answer period to take your questions, which you can use the chat to let us know you have a question, or to write the specifics of what that may be. Peter, I'm going to turn it over to you.
Great. Thanks, John and Diane. Well, hi, everybody. I'm Peter Arsenault. I'm the founding president of Greening USA and current board member. And we're delighted to have the discussion about climate change come into focus here today. Right in Central New York's backyard at LeMoyne College, there is a Center for the Study of Environmental Change, and that's headed up by Dr. Lawrence Tanner, who's professor and is joining us today. He's professor of environmental science systems at LeMoyne, but he also serves as the director for the center. The center is kind of an interesting place. It serves as a node for the coordination of educational research and outreach activities related to the environmental effects of Earth's changing climate. So by supporting the study and understanding these effects in the local and global environment, this center at LeMoyne promotes a more just and sustainable society consistent with Jesuit values and societal values in general. So it's often we hear about the SUNY ESF, but LeMoyne is doing some great things as well. So Dr. Tanner is going to speak to us about some of the work at the center and some of the things that are relevant to all of us. But before that, we're also joined by Teresa May, who's the Associate Director of Catechesis at the Roman Catholic Diocese of Syracuse. She's been very involved in a faith-based response to climate change, which has to do with the Pope writing several years ago an encyclical, a letter called Laudato Si, and it talks about caring for our common home, which is the planet Earth. So it's meant to be non-denominational, but it's a very candid look at things and cooperative look, and it actually provides us a lot of hope for the future. So Teresa is been very active in this effort within the diocese and our own parish, and we all know that the Padwasani are famous for saying we want to think about our actions and how they affect the next generations, the 7 generations. Well, Teresa says she's very proud to be the mother of 3, grandmother of 4, with 2 great-granddaughters. She doesn't look old enough for any of that, but nonetheless, she's looking at future generations, and I think we can all join her in doing the same. So I think, Teresa, you're going to start, is that correct? So yes. I'll send it over to Teresa. Thank you and welcome.
Great, thank you. Wonderful. I know Larry's getting up our slides for us. I'm really grateful to be here. Thank you for inviting me to be part of Greening USA and this talk on climate change. As Peter mentioned, Pope Francis released an encyclical entitled Laudato Si. This is what it looks like, in case you haven't seen it. A papal encyclical is a very important document that comes out of the Vatican and is usually addressed to bishops and clergy, sometimes to the lay people, on matters of church doctrine. This is a unique document. It's meant to be a teaching for all people, appealing to every person on the planet. The message of global warming isn't anything new for us in the scientific community, or for those of us who even watch the evening news. We can see changes happening daily around the world. And Dr. Tanner is going to address some of those things in a few moments. What Pope Francis has asked us to do is nothing less than a conversion of mind and heart. The global ecological conversion to an awareness that all our actions and inactions directly affect our planet, in particular, the poorest of poor and the children in our future. This encyclical awakens us to that urgent challenge to protect our common home, which is in crisis. And although it's an official teaching of the Catholic Church, its message reaches beyond religious affiliation, ethnicity, borders. It is meant for all of humanity, all of creation. What you're looking at on the screen is a movie, a very powerful movie that follows the lives of 5 people who've been directly impacted by climate change. They're from the Amazon, India, Africa, and Hawaii. And their journey highlights their meeting with Pope Francis. They represent the poorest of poor, teens, young people, indigenous people, and nature. There will be a free showing of the letter at Liverpool Library on Saturday, April 15th at 2 o'clock. Be followed by discussion. And then the following week, it will be shown at the Art Rage Gallery on Holly Ave in Syracuse on Wednesday, April 26th. I'm not sure what time, might be 6:30 or 7. So we'll get back to you on that. And I really recommend this film for young people, 6th grade and above, for teens, for young adults, parents, for all people. We'd like to show you just a 2-minute clip from the movie, The Letter, and encourage you to join us at one of these showings. One of my favorite quotes in the movie itself is, "Once you know, you can't look away." And one of the young people in the video says, "Be the change." So let's look how we might do that. Is it working?
Can
Larry,
everybody see and hear?
No, we don't see anything, Larry.
Oh,
We just see the slide.
hmm.
You may have to stop sharing and then reshare.
Oh, you know what? You're absolutely right. It's been a while since I've done Zoom teaching where I had to do this, so I forgot that I had to do that.
Yeah,
So-
and don't forget, Larry, I think there's an extra setting for hearing sound from a video as well.
the Vatican releases Pope Francis's wildly anticipated encyclical on
There
the
we go.
environment.
La naturaleza grita. Deténganse. Deténganse. Refuge climatique. Un manque de la protection de la nature qui pousse aujourd'hui de nos populations à quitter chez nous.
É perder a terra, a floresta, o grande agronegócio que está chegando aí.
Marine heat waves are causing an unknown amount of death among corals.
I want all the global leaders to do something to stop climate change, because if it's not going to be stopped, it's going to harm our future.
Queridos poetas sociales, porque ustedes son poetas sociales porque tienen la capacidad y el coraje de crear esperanza allí donde solo aparece descarte y exclusión. Je n'arrive pas à rester tranquille. Parfois, j'ai un esprit qui voyage.
O mundo vai mudar. Porque o que estava encoberto, hoje está sendo descoberto.
Il faut lisser des liens très forts et il ne faut jamais rompre ce lien.
You are my hero, you are.
Che nessuno di noi è un'isola. Abbiamo tutti bisogno gli uni degli altri. Wondema, pour himbe mbada protéger l'environnement.
Try to be the change you want to see in the world.
We arrived as individuals with very different stories, but we all shared a dream.
Thank you, Larry.
Okay, Teresa, are you done?
Yes,
All right.
over to you.
All right. Okay. Yes, so I am Larry Tanner. I am a professor at LeMoyne College, and I'm in the Department of Biological and Environmental Sciences. My training is actually in geology, and as part of my teaching load, I teach geology classes that are within the environmental science major. My research as a geologist includes the study of climate, although I'll preface that with, I don't study modern climate. I study the climate of the deep past. In other words, I use the geological record to study the changes in climate that have occurred over hundreds of millions of years ago. So that's my background coming into this examination of climate. Well, in 2015, Pope Francis released his encyclical Laudato Si on the care of our common home, although I think that the title might be better, The Threats to Our Common Home. And really, this lecture that I'm presenting today is more of an exploration of how Pope Francis developed this. What is the information? What did he use to actually produce this encyclical? So it's a look at climate change, and there's a lot of information here that's very, very basic to many of you. Probably everybody here has seen a lot of the information that I'll be presenting, but I am trying to present it in a way that will be useful for people when they are discussing climate change with other people. That's really my purpose here, is one, to show how Laudato Si is actually relevant to the subject of climate change, but also to present to the audience here, even though I am preaching to the choir, as they say, what is the information that you can use to actually explain climate change to other people? So Pope Francis, as probably everyone is aware, he's from Argentina. You know, his given name is Jorge Bergoglio, and he's a huge soccer fan. And so I wouldn't be surprised if he sponsors Lionel Messi for sainthood at some point. But he also has an interesting background. A lot of information came out about him after he was surprisingly named the successor to Benedict. One, that he is the first Jesuit to ever become Pope. Other portions of his background, at one point he was a nightclub bouncer. At another point, and this is a little bit more relevant, he worked as a chemical technician. He had training and received a degree in chemical technology. So he's not a stranger to the natural sciences. Now, in developing the encyclical, and there was a lot of anticipation about the release of this document. And actually, I'd like to, I just want to pull this out of the way a little bit here. So I'm using a lot of quotes from the encyclical. So everything that you see that has the tag LS, this is a direct quote from the document Laudato Si. Now, in developing this document to address the environment, it's not entirely about climate change. In the run-up to the release of Laudato Si, there was a lot of discussion about the appropriateness of a pope addressing a scientific issue like climate change. And it isn't entirely about climate change, but it does specifically address climate change. And it addresses it in a very serious and scientific manner. And in developing his document, he consulted with the Pontifical Academy of Sciences, which includes several climate scientists. So when he says that there's a very solid scientific consensus, he means that, or he has the backing of real, genuine scientists that are telling him that, yes, this is the scientific consensus, that we are seeing a dramatic change in climate. So here you see from one of the British authorities, a global temperature change graph from 1850 through the present. Now, the year 1850 is a fairly logical starting point, because this puts us squarely within the period of the Industrial Revolution. And you might notice that, there are actually several different lines here that are overlaying. These represent computer models that are calculating global mean temperature from the data. Because when you're combining data from all different locations around the globe, and there are obviously a lot of holes in that coverage, there are different ways of calculating what that mean temperature is going to be. But you can see they overlap pretty closely, and they show that there has been this significant change in temperature, a change in temperature of about 1.2 degrees Celsius, which is equivalent to 2.16. I calculated this out the other day just to be sure. 2.16 degrees Fahrenheit change in temperature over this period. Now, another reason for starting this graph in the year 1850 is because we have reliable temperature records going back that far. Technically, you can say that the thermometer was developed in the very early 1800s, but there is a lot of room for maneuvering around the consistency and the accuracy of the very earliest thermometers. So by about 1850, we can say that we can rely on these instruments to give us accurate readings of temperature. So this shows that, yes, there have been a little bit of variations in where it's gone up, then it's gone back down, but in particular, over the second half of the 20th century, you've seen this really, really steep rise in temperature. Now, in order to understand why the temperature is rising, we have to consider, well, where is the energy coming from? Well, it's coming from sunlight. So incoming solar radiation, which is primarily in the form of visible light, it's light within a fairly narrow spectral range for which our optic systems have evolved to detect, which is why we call it visible light. That's what's coming in from the sun. Now, about half of that incoming radiation, which averages, if in energy terms, it's about 340 watts per square meter. And this is orders of magnitude larger than the amount of heat that actually radiates from the inside of the Earth. So basically, for practical purposes, all of the energy that we have is coming from the sun. About half of that incoming energy is reflected by the atmosphere and by clouds. So only about half of it is actually reaching the surface. So the visible light is reaching the surface of the Earth. Now, that visible light gets absorbed by the surface of the Earth, by the land, the water, the rocks, the soil, the plants, and it warms up the surface, which then releases that energy back to the atmosphere in the form of infrared radiation or long wave radiation. And that's the important point. This incoming visible light just goes right through the atmosphere. It doesn't interact with the gases in the atmosphere. But the long wave radiation that is re-emitted from the surface, that does interact with the atmosphere, and that's what creates the greenhouse effect. Without the greenhouse effect, basically the Earth would remain frozen. So the greenhouse effect is what makes the Earth livable in the first place. Now, the greenhouse effect, and here the greenhouse effect is explained within the document Laudato Si. Greenhouse gases, and it lists carbon dioxide, methane, nitrogen oxides. And of course, the best known of these is carbon dioxide. Now, the feature of these particular gases that makes them greenhouse gases is that there is something about their molecular structure that interacts with this long wave radiation. The radiation is absorbed by these particular molecules and it causes them to vibrate. And when you put molecules in motion, that's heat energy. The heat of the atmosphere is simply the kinetic energy, the movement of the molecules in the atmosphere. So most of the atmosphere consists of these very symmetrical molecules of dinitrogen and dioxide, 2 atoms of nitrogen, 2 atoms of oxygen. That's 99% of the atmosphere. And the infrared energy doesn't interact with those molecules at all. But it does interact with carbon dioxide. Now, I'll also show you that it interacts very strongly also with water vapor. And in discussions of greenhouse gases, we almost never talk about water vapor. And that's because water vapor controls itself. The water in the atmosphere is simply a function of rates of evaporation. When it's warmer, you have more evaporation and you have more water vapor in the atmosphere. When it's colder, you have less evaporation. There's less water vapor. So we don't really deal with water vapor in the atmosphere because that's not something that we control. It's self-controlled. Carbon dioxide, that is an entirely different matter. And my work as a geologist studying ancient climate shows that over the course of hundreds of millions of years of Earth history, the primary control on Earth's climate has been the amount of carbon dioxide in the atmosphere. Now, many of you may have seen this particular diagram before. This is what's called the Keeling curve. In 1958, Charles Keeling, a scientist with the Scripps Institute of Oceanography, got the idea for measuring CO2 in the atmosphere from an observatory on the flanks of Mauna Loa volcano at an altitude of a little over 11,000 feet above sea level out in the middle of the Pacific Ocean on the big island of Hawaii, free from anthropogenic influences. And these measurements show that over the decades, and these measurements have been continued in the decades since Charles Keeling died. They've been continued, and they show that there's been a steady increase in the amount of CO2 in the atmosphere all through this period. Now, he only started this in 1958. So when he started the measurements, we were looking at about 312 parts per million. That's how much we're talking about in the amount of CO2 in the atmosphere. We're talking about hundreds of parts per million, not parts per thousand, but parts per million. So currently we are at 421, I believe was the last measurement that I saw recorded, 421 parts per million from last spring. So, which would be 0.04%, which doesn't really sound like much, but it has an impact because as the amount of CO2 in the atmosphere increases, the amount of infrared radiation that is absorbed by that CO2 in the atmosphere also increases. We estimate that at the start of the Industrial Revolution, or the pre-industrial levels of CO2 in the atmosphere, were 280 parts per million. So from 280 to 420 is a full 50% increase in the amount of CO2 in the atmosphere. Now, of course, we know where that CO2 came from. We put CO2 in the atmosphere through all sorts of anthropogenic activities, but primarily through the burning of fossil fuels. Yes, the production of cement does contribute a not insubstantial amount, but compared to the amount that's produced by burning coal, oil, and natural gas, it's still fairly small. So fossil fuels are the main source of the CO2 in the atmosphere. And you can see that, over time, as population grew, as industrialization increased, as the economic activity of societies increased, the amount of CO2 that is produced by this by human activity has also increased. Now, who has produced the most of it? Well, guilty. Now, that's, over time. Currently, China is the largest producer of CO2. It's the biggest emitter, but not by all that much. They are the most the largest producer currently. But the fact that we had 100 years head start on China in terms of industrialization has led to us having outstripped all other countries by far in terms of cumulative emissions. And so we're looking at production over time of hundreds of billions of tons of CO2. And when you see tons spelled with two N's like that, That means that we're talking about metric tons, and a metric ton is 1,000 kilograms. So it actually means 2,200 pounds, not 2,000. So hundreds of billions of tons of CO2 have been produced. Well, if you add up all of these, it comes to over, well, we're talking over 1 trillion tons of CO2 that have been produced by anthropogenic activity over time. Now, fortunately, all that CO2 doesn't stay in the atmosphere. It becomes part of the carbon cycle. A certain amount is stored in the atmosphere. Now, before the Industrial Revolution, the amount of CO2 in the atmosphere is estimated at something around 600 billion tons. And this diagram is actually a little bit out of date. It's closer to 900 billion tons in the atmosphere at present. Now, as we pump CO2 into the atmosphere, we have CO2, we have that carbon being taken up by photosynthesis. So photosynthesis in the plant world removes a substantial part of it. But the thing is that plants respire CO2 also. Plants use energy, the cells use energy, and so as they use energy, each cell in a plant is also producing CO2. So some of that gets released directly back to the atmosphere by the respiration of the plants. Now, of the plant material, some of that is consumed, and those consumers respire CO2 back to the atmosphere. Some of that plant material dies and decomposes, and the decomposition of that plant material produces CO2 also. So even as the amount of CO2 in the atmosphere increases, and that increase in CO2 in the atmosphere can actually help boost photosynthesis to a small extent, you still put most of that CO2 back into the atmosphere. So you can't depend on photosynthesis to take all of that CO2 out of the atmosphere. Now, photosynthesis also takes place in the ocean. You have photosynthetic microorganisms, lots of algae that live in the ocean, they're photosynthetic. And some of that can be, of that plant material in the ocean can be buried, just like some of the plant material on land can be buried and sequestered from the atmosphere. CO2 also dissolves in the ocean. But that is an exchange that varies as the amount of CO2 in the atmosphere varies. You put more CO2 into the atmosphere, more CO2 dissolves in the ocean. That's what causes ocean acidification, is the increase in dissolved CO2 in the ocean waters. But also, as the ocean warms up, it loses its capacity to dissolve that CO2. The solubility of gases in water decreases as the temperature rises. So we can't count on the ocean to absorb all the excess CO2 either. So that means that as we continue to put more CO2 into the atmosphere than either photosynthesis or dissolution in the ocean can accommodate, it increases in the atmosphere. And the result is climate change. So here you see a representation of temperature changes over a 50-year interval, starting in the later 20th century through the early 21st century. And there are very few places on Earth where the temperature has not increased. You'll also notice that at the higher northern latitudes, the temperature has increased more than it has at lower latitudes. And that's a point that I'm going to come back to as well. Now, what about temperature change just in the United States? If we just focus on the US, here is data And the double zeros after each one of these years, it represents the monthly interval. So it represents a full year period. Each one of these data points represents a calculated mean temperature for the lower 48, for the contiguous United States. So averaging a mean temperature over the entire calendar year for the entire 48 states for each year is represented by 1 point on this graph. And statistically, you have a fairly significant relationship here. You see that temperature has increased, and this goes up to the year 2020. And over that period, it's increased a little over, the mean temperature is increased a little over 2 degrees Fahrenheit. This scale is in Fahrenheit degrees, not Celsius. And so that's about the same as the global change in temperature. 1.2 degrees Celsius is a little over 2 degrees Fahrenheit. And this is data that's publicly available from the NOAA website. Well, the Paris Agreement. This is the agreement that countries signed on to in 2015 at the COP21 meeting. And the agreement was that we were going to try to keep temperature change to try to keep it below 2 degrees Celsius and shoot for a goal of 1.5 degrees Celsius. Well, right now they're saying that, we're already at 1.2 degrees Celsius, and that even if we hit all of our emission reduction goals, we're going to shoot past that 1.5 degrees Celsius probably in the next 10 years. This is from a report that was in the proceedings of the National Academy of Sciences. But if we do cut our emissions significantly, if we actually reach those goals, after the overshoot, we could pull it back. So it's not a done deal that we can't do anything about it. It might take a few extra decades, but we could bring it back down under 1.5 degrees Celsius at some point between 2050 and 2060 with significant reductions, or basically if we can zero out our carbon emissions. And just for the record, the goals that the U.S. set for the Paris Agreement, the U.S. is not that far off from reaching those. They're actually quite attainable. So in particular with the current legislation that was passed as part of the Inflation Reduction Act, we could easily meet our commitments under the Paris Agreement. Okay, now as temperatures increase, of course, one of the things that has been quite visible and quite well publicized is the decrease in sea ice in the Arctic. And you see that there's been a very, very pronounced and regular decrease in ice coverage in the Arctic Ocean. And this has major consequences. I mentioned that in a view of global warming, or the global amount of warming, that you saw that the high northern latitudes that were warming significantly faster than the lower latitudes. This is why. The ice reflects sunlight back through the atmosphere, back out to space very, very effectively. It has what we refer to as a high albedo, the percentage of reflected energy. Water has a very low albedo. Water absorbs solar energy very effectively. So as the amount of Arctic sea ice decreases, that means that there is more solar energy being absorbed by the Arctic Ocean, which warms those northern latitudes. This is a feedback effect that once you start doing this, you are changing the system by decreasing the amount of ice and increasing the amount of open water, which then increases the amount of warming, which then decreases the amount of ice even more. So you get into a feedback loop. And as noted in Laudato Si, this warming has consequences for the areas surrounding the Arctic. Because the warming of the air causes warming of the land, and areas where you have a lot of organic carbon that is frozen in permafrost, those areas are now subject to higher temperatures, and thawing of the permafrost allows the escape of methane, which is produced by anaerobic decomposition of organic matter, and carbon dioxide, which is produced by the aerobic decomposition of organic matter. So this is another part of the feedback. So, and this is something else that is drawn, to which attention is drawn in Laudato Si, is this feedback in the Arctic lands through the warming of the Arctic. This part is, it's actually somewhat alarming that you have underground fires, and these are seen from satellite photos, fires that continue burning in peat that is stored underground that can burn through the winter. And of course, all that burning is turning this organic matter into CO2. So this is a consequence of this feedback loop, which is warming the Arctic. And that last quote also drew attention to melting of the ice caps. So this is another facet of the problem that's very well known. Melting glaciers. In particular, glaciers, the ice caps in Greenland and Antarctica. These, in both places, these have become unstable. The Greenland ice cap is melting rapidly, enough that we can project that melting in Greenland is going to be causing possibly another 10 inches of sea level rise just by mid-century. And this is without considering the instability of the glaciers in Antarctica. For a long time, we really didn't know what was going on in Antarctica, how much global warming would impact the Arctic glaciers. Now we know that these are also being destabilized by the warming. And of course, the consequence of rising sea level is that it impacts coastal regions. Now, a small rise in sea level might not seem like that much of a threat to a city along a coastline. But the thing is that small change in sea level means that during storms, the storm surges can reach much farther inland. So this is really the danger of rising sea level, is the threat that is posed by coastal storms to coastal inhabitants. And we see that there is a very clear correlation between the rate at which the glaciers are melting and the rate at which the sea level is rising. And most of the sea level rise can be directly attributed to the melting of the glaciers, in particular, the Greenland glaciers. Mountain glaciers don't contribute nearly as much to sea level rise as the Greenland ice cap does. Now, up until the late 20th century, sea level rise was actually more a factor of the expansion of ocean water as it warms. But starting in the second half of the 20th century, it's the melting ice that has actually produced most of the sea level rise. Now, the increasing temperature of the atmosphere also energizes the atmospheric circulation system. The primary system of atmospheric circulation is caused by convection, the rising of warm air in low latitudes and its descent towards the Earth's surface in higher latitudes. And by increasing the amount of energy in the system, basically we make the energy more vigorous and we increase the rates of evaporation at low latitudes. In short, as a takeaway for how is atmospheric circulation changing, or how is global climate changing as a result of the increased temperature, we can say that the wet areas are going to get wetter because there will be more water in the atmosphere because of increased evaporation, and dry areas will get drier because of the increased energy of the convection. Now, just before the start of this session, we were having a little discussion about Cyclone Freddy out in the Indian Ocean, an extreme cyclone that's set a record for the longest lasting cyclone on record. Well, one of the predictions of climate change is, and this is something that climate scientists were predicting decades ago, is that as the climate warms, you're going to see an increase in extreme weather events. And Laudato Si uses that exact phrasing, extreme weather events. Now, not necessarily that extreme weather events become more frequent, but they become more extreme. The storms become stronger, longer lasting. So hurricanes, for example, and here you see some of the aftermath, the catastrophic destruction from Hurricane Katrina back in 2005, causing over $100 billion in damages, and well over 1,000 people died as a result of this hurricane. So hurricanes by themselves are not necessarily going to become more frequent, but what we are seeing is that the higher category hurricanes are becoming more common. In other words, of the hurricanes that do occur, more of them are category 3 or higher than they used to be. More recently, the destruction from Hurricane Sandy, although when it came ashore when it reached New York, it had downgraded to a tropical storm, but still it caused absolute devastation in along the coast of New Jersey, and Long Island absolutely demolished some communities. So, and that was in 2012. And actually, it was fairly late in the hurricane season, 2012. It occurred well into the fall, because I know that schools were well in session. I'm trying to remember the exact dates of it. It might have been mid-October, but yeah, this is part of this trend that hurricanes are becoming stronger events, not necessarily more frequent, but stronger. They are more extreme. And this applies also to both heat waves and cold waves, that the highs become higher, the lows become lower. We have more extreme weather than we used to. The wildfire season in the US, that's becoming more extreme. The wildfire season in the West starts earlier than it used to, and it lasts longer. A major part of the reason for that is the decrease in snowfall, the decrease in the snowpack of the Western mountains. Now, aside from the huge snowstorms that they just had out in California, I'm talking over the Western states in general. We've seen over the past decade and a half that there's been a drop in the amount of snow that accumulates every winter season. And this means that when the spring season starts, there is less snow melt, less moisture, and this allows the fire season to start earlier. That combined with higher summer temperatures just increases the chance of wildfire. Now, along with that, this decrease in snowfall, you also have a decrease in river flow. And just in this past year, there's been a lot written about the problems with the Colorado River and the fact that the Colorado River is flowing at such low levels compared to what it used to. And the number of communities, the different states that actually depend on the Colorado River, and they're coming into a crisis where the old agreements of who can have how much water, those agreements just aren't going to make it, they're not going to mean anything anymore because there's not going to be enough water. So over the past century, we can see that there's been a regular decrease in the amount of water carried by the Colorado River. Now, mountain glaciers don't contribute much to sea level rise, but they are a major source of water for a number of communities in a number of nations. In mountainous regions in the Andes and the Himalayas, you have these glaciers, the ice melt from the glaciers during the summertime, providing the water flow for a lot of people, large populations. And when these glaciers melt away, that's a loss of that water supply. The dry regions getting drier as part of this predicted consequence of climate change. It means that in a lot of regions that depend on subsistence farming, that subsistence farming is no longer possible. And this causes a lot of displaced people. So we are seeing climate refugees in a number of regions in sub-Saharan Africa, in Asia, and even in Central and North America. Now, the migrant crisis that we see, the number of migrants that are arriving at the U.S. border, it's not entirely due to climate crisis, certainly not. But the climate crisis is contributing to this because some of these people that are leaving their homes in Guatemala and Honduras and Mexico, some of these people are leaving because they were farmers and they can no longer make a living farming. So they're trying to find someplace where they can make a living doing something else. So it is a part of the immigration problem. It's one of the roots of the immigration problem, certainly not the only one, but it is a contributing factor. So some of these people are climate refugees. We're seeing increases in certain diseases. And in particular, insect-borne diseases are spreading. Now, malaria, this is a fairly easy one. The range of malaria is increasing simply because the areas where the mosquitoes can live has increased. It's a function of both temperature and, of course, precipitation, because mosquitoes need wet areas in which to breed. But we're seeing that the range of the mosquitoes that the Anopheles mosquito that transmits malaria, the range of that particular mosquito has been increasing in recent decades. You could say the same thing about Lyme disease in this country. The deer tick that transmits the Lyme disease, the range of that particular tick has increased in recent decades as well. So there are a number of these types of insect-borne diseases that are spreading because of changing climate. Now, the encyclical draws attention to coral reefs, and in particular, the fact that coral reefs are home to the major biodiversity of the ocean. Most of the largest concentration of biodiversity in the ocean is found in coral reefs. And coral reefs are threatened by climate change. Coral bleaching is a result of the corals expelling the algae that lives symbiotically with them. That's what gives coral its color. It's the coral itself is made of basically limestone, calcium carbonate, with these little tiny coral polyps, these little animals that live symbiotically with photosynthetic algae. And it's the algae which that give the coral their colors. But when the coral polyps become stressed by rising temperatures, they will expel those algae. Now, that doesn't mean that the coral is dead immediately. If the temperature comes back down, the algae can be reestablished within a bleached reef and the coral can recover. But if the coral remains bleached for too long a period of time, then the coral polyps die and the reef dies. And if the reef dies, you lose a lot of the biodiversity, which includes a lot of organisms on which people depend. A lot of communities depend on the coral reefs for the fish or the shellfish that they collect. This is just a map that shows a comparison that shows areas of the Great Barrier Reef in the northern part of the Great Barrier Reef in Australia that underwent very severe bleaching over a period between 2016 and 2017. Now, the northern Australia, this is closer to the equator where the waters are warmer. The southern parts of the Great Barrier Reef were not so strongly affected, but the northern part of the Great Barrier Reef was very, very strongly damaged by these bleaching events. Now, I said early on that Laudato Si is not entirely about climate change. It discusses problems with the environment in general. So it also talks about other types of environmental degradation, including deforestation. And when we think about deforestation, of course, we think about the Amazon. Now, the Pope frames all of this discussion is under the heading of degradation of the environment also degrades the human environment. In particular, it affects the poorest peoples, though the people that have the least protections are most susceptible to being damaged by changes in their ecological environment. So he relates all this to humans, but it does show a concern for the natural environment. Now, aside from the quote from Laudato Si, I show you a figure here from the World Wildlife Fund that over a period of about 50 years, what we've seen is that wildlife populations have dropped by an average. This is on land. Wildlife populations have dropped by more than 2/3. The number of animals in the wild has decreased precipitously over the past half century. And this is a figure that I just saw cited in the journal Nature I think just last week. that if you calculate the biomass of humans, the 8 billion humans on Earth, population is 8 billion now. It comes to around 400 million tons. If you calculate the mass of all the other mammals on land, so elephants, white-tailed deer, kangaroos, lions, city rats, calculate the mass of all the other mammals on Earth, it only comes to about 50 million tons. Humans dominate the Earth like no other species ever has. No other animal species ever has been so dominant on the surface of the Earth in all of its history. And this particular quote from Laudato Si, that species have value in themselves, that it's a sad thing for the species to go extinct. And that's what we're seeing right now. Now, most of this loss is because of habitat loss. Most species extinctions and declining populations are due to habitat loss. Some species go extinct or are nearly extinct because of poaching. A few are the direct result of climate change, but most of them is simply because we have taken over the land where the animals used to live, and we're using it mainly for agriculture. Now, the Pope draws attention to our consumer society, the fact that we're always using resources and that we are using these resources faster than they can be replenished, which is where the concept of Earth Overshoot Day comes from. In any particular calendar year, you can calculate when we have used the amount of resources that would be produced in that year. And they're gone for the rest of the year. And for last year, July 28th is when we hit that overshoot day, when we had used up the resources that would be produced within the calendar year of 2022. The pollution, the throwaway culture, the Pope calls these out as factors in the degradation of the Earth environment. The plastic in the ocean, the amount of waste that is produced by our, quote, civilizations, that we make things and use them once and throw them away. This is his cause for concern. And he's trying to draw attention to this, to try to get people to think about this more. Do we need to buy a new cell phone every year? Or even every other year? Well, Apple Corporation says yes. But, producing these things, producing all of these goods, it requires resources, and in particular, these technological electronics. Now we're seeing that all of these, the computers, the cell phones, even the electric vehicles, they require a lot of exotic materials, in particular, the rare earth elements. And that, well, if we're going to build these things, we have to extract them from the earth someplace. And in some places, these materials are obtained illegally by illegal miners within national parks, or they are obtained by child miners. So there's a lot of consideration that needs to be applied to our entire consumer society. And people need to act. Now, I'm proud to say that I was part of this event, the People's Climate March in 2014, September in New York City. There are actually a number of these marches that took place around the world, but the one in New York City attracted 400,000 marchers, and we loaded up a bus of LeMoyne students and drove down to the city. We left. What time did we leave in the morning? Oh, it was like 2 o'clock in the morning that we left campus to get down to the city so that we could get in line. We lined up on Central Park West and marched all the way down to I think it was about on the lower west side, down around maybe 20th Street. It was a long day of marching, I'll tell you that. But it was great. There were students from universities all over the country. There were indigenous groups, there were faith groups, there were people from other countries that came to this. It was a great event, and it coincided with a UN meeting on climate change. Now, reducing our use of materials and trying to decrease our emissions might not be enough. And so there is a new movement, this Foundation for Climate Restoration is a movement, and you can check out f4cr.org, that believes that we need to start investing in projects that are actively removing carbon from the atmosphere. And there are different ways in which we can go about this. This was a story that I saw, just a couple of weeks ago, a few weeks ago in EOS, a publication of the American Geophysical Union, where a biotech company has genetically modified poplar trees that will grow 50% faster than normal poplar trees. The idea being that you can create a source of wood that grows faster, and so it pulls carbon out of the atmosphere faster. And then if you actually build something with that wood, that carbon is removed from the atmosphere for as long as that wood remains. So that's one approach. Now, everyone, I'm sure, is familiar with movements for replanting forests, which is reforestation, and afforestation, which is planting trees where they haven't grown previously. But, the simple fact is that it's not possible to plant enough trees because of the requirements for a tree, the water, the nutrients that are required for a tree to grow. It's not possible to plant enough trees to grow fast enough to really remove a large amount of carbon from the atmosphere. If we had planted them 20 years ago, yeah, it would be fine. And in fact, there's an old Buddhist saying the best time to plant a tree is 20 years ago. But it's, planting seedlings now, and unless they're these genetically modified trees, they're not going to able to make that much of a difference. It's certainly worth contributing to the removal of carbon from the atmosphere, but they're not going to be the answer. So we might need something more aggressive. Now, there is already a plant, it's called Orca, in southern Iceland, an experimental plant that takes carbon directly out of the air and pumps it underground, where it reacts with minerals underground, and just, the carbon turns into mineralized material. It stays underground. The initial plant is a very, very small scale operation, and a Swiss company now is investing in building a much larger plant to try to scale this up. And this could be a partial solution, is that if we have a number of these plants worldwide that are capable of, at a larger scale, of removing millions and billions, eventually billions of tons per year from the atmosphere, then we could really do a reversal of climate change. That's really what it would take to really reverse climate change, to get back to, say, 350 parts per million. It really means removing carbon from the atmosphere that's already there, not just reducing our current emissions, but taking it out. And so, as the book says, many things have to change. And that sort of reminds me of a line from the novel The Leopard by Lampedusa, or in Italian, Il Gattopardo. In order for things to stay the same, everything will have to change. If we want to save Earth's climate, we're going to have to make some major changes. And if we want to save our planet, the Pope would say that we have to enlighten the people in charge. We have to make them understand what's at stake and what good can come from it. So that is the end of my prepared comments.
Very good. Well, thank you, Larry and Teresa. Lots of good information there. In addition to the recording, I suspect we can make the slides available. Is that amenable to you if people would like a copy of the presentation?
I would be happy to do so, and we can figure out a way to transfer the file, because the file size is,
sure.
I'm not really sure exactly how big the file is, but it might be a little bit too big for email, but I could share it through Dropbox or something like that.
Okay, we'll work that out separately and let everybody know. We do have a few people who would like to have, I guess we've got maybe a few minutes for discussion or questions. Maybe, what do you think, John? Do we want to do it in the chat, or do we want to do people raising their hand?
Oh, actually, before we start, Teresa was providing some dates for showings of the film, The Letter, and I really highly recommend the film. It's a beautiful film, and it's only an hour and 20 minutes, so it's not a huge commitment either. There's going to be a showing of it on March 21st, Tuesday the 21st, on the LeMoyne campus, at 7 o'clock in the evening, but they have not indicated which building it will take place. But if you check the LeMoyne events calendar, eventually they will be posting the location for it. So that will be coming up in, just a couple of weeks here.
Yep. All right, so that's in addition to the two that Teresa mentioned, and we will be providing more details on the Greening USA newsletter that many of you receive, and we hope to see you there. There will be a chance for discussion, we hope, after each of those showings, briefly, but more importantly, opportunities for people to get more involved. Well, I'll tell you what, down in the reactions area, if you click on reactions, if you have a question or something you'd like to do, hit the raise hand button, and maybe we'll call on as many people as we have time for. We would like, if you have a question, that would be preferable to another presentation, but if you have a question for Larry or for Teresa, why don't we open it up for that? I see a few comments in the chat saying that excellent presentation, asking about opportunity for discussion. At least one person has said, very sobering, we all need a reminder of the stakes. And thanking Larry for his well-conceived presentation there. I particularly like the comment that you're saying that yes, some of us have heard some of this before, but this really gives us something to be able to talk to others about it. I think that's great, and I think that's what the purpose of the movie is, to give us the opportunity to look at the broader picture and engage in more dialogue. Someone is asking if there are any local projects that we can get involved in. Funny you should ask. Greening USA has a committee called the 12 Traits Committee, which is basically, the full name is the 12 Traits of Sustainable Communities. And we're very involved in wanting to do, well, get the message out. You know, the 12 traits address the environmental, the economic, and the social impacts of what we do. You know, the big word that was used, anthropogenic, you know, it's what people do. All right, it's people and their activities, right? I think the best way to do that is to get involved. If you'd like to help us in getting the word out about solutions, which is what the 12 traits is all about, we'd encourage you to contact us at Greening USA, and we'll show you ways to get involved. There's certainly other organizations too. There's certainly things that we can do with personal actions. Someone's suggesting electric cars, electric houses, decreased consumption. Yes, avoiding, that's part of the 12 traits. So get off of fossil fuels and stop being wasteful. We do have a question from Jim Delosio. Jim, congratulations on your recent award, by the way. What do either of us see as the role of faith communities? Teresa, do you want to take that?
Well, one of the things that we are always talking about is education, to make people aware that of the issues, and that we have a personal moral responsibility to take care of the planet that we all share, and not to use all the Earth's resources just for ourselves. Yeah, so I think it's helpful that parishes have committees or teams of people that are looking at their own churches to see how they are affecting the environment, if they're helping it or hindering it. So education, I think, is first.
Larry, do you want to add anything to that?
Well, actually, I thought that maybe Dave Babcock might want to jump in here. Dave is leader of the local diocesan Care for Our Common Home Task Force.
I could just be real brief and say that I think for me personally, and I think for members of our task force, it's both education and from a faith perspective, those of us who believe in God, that there's a conversion engaged with all this, that we're all interconnected. A lot of the points that Pope Francis makes in his encyclical letter. So the connection that we all have, the spirituality of it, as well as the education, and then lots of other things flow from that.
Yes, there is an ecumenical group that's active in Central New York that is also involved in this, and I'm blanking on the name of it. I did a presentation for them about a year ago on the 12 traits. There's also Interfaith Power and Light, Jim Delosio was pointing out, and the Foundation for Climate Restoration, the F4CRCNY that Larry mentioned. Richard Schutzbau is saying that the email address is f4crcny@gmail.com. That's in the chat if you'd like to engage with them. And they have local events to be involved. And we're also being reminded by Luann that Stop Dirty Banks by Third Act is a way to, I guess, work with banks and investment companies that are investing in fossil fuels. That was a question that Luann had I think that's a that's an interesting approach, and just like we're talking about faith-based responses, this is an investment in banking response. Maybe we should do a green bag lunch on that one day and get some speakers to address that, because we could probably delve into that pretty deeply.
Could I jump in there for a second? In the past, a couple of years ago, we had, I think, a couple of green bag lunches on sustainable investing. So I'm a huge proponent of each one of us taking responsibility in any small ways that we can to move the needle, because there's so much that we do that contributes to the problem every day. You can take a look at your retirement account. I know that I have personally badgered my investment counselor for years, and I've gotten him to move the needle and move over to some sustainable investing, which he initially poo-pooed to the highest. Oh, you'll never earn any money on that. So now he's moving the needle. Each one of us can help to move the needle in those ways. But there is a person in central New York, Caitlin Creasel, who is very well versed in sustainable investment. And there's I can't remember the name of the company she works for. It's out in Manlius. But that's what they specialize in, is sustainable investing. So that's another way to, speak with your money. Back when I was not retired and I was specifying millions of dollars worth of products on projects I was working on, I was constantly badgering companies to up their game on sustainable products in so many ways. And I was really surprised, not necessarily because of what I was doing, but to watch how the product industry, how quickly it's changed and how they've taken on some responsibility. So it's up to each one of us really to keep pushing the needle.
Yeah, along those lines, and before I make a comment, I did see that Don had his hand up. Don, did you want to say something, or is your hand raised inadvertently?
No, I did. I put a few things in the chat. I listed some other groups. I'm involved with the Sierra Club as conservation chair. But there's other groups like Agree and CCAA you can contact. I wanted to make the point that carbon dioxide, if you get into any discussions with people about climate change, carbon dioxide is the main culprit because it lingers, it stays in the atmosphere. Once the horse is out of the barn, it's out, and it will be with us for hundreds of years in the atmosphere, and it's cycling around the in and out of the oceans and in and out of the land. I'm pretty skeptical when it comes to these contraptions to siphon CO2 out of the air, because it's just so much easier to stop emitting the carbon dioxide in the first place. So just want to make those comments.
Yeah, thanks, Don, for those. And, and along with all the other suggestions that people have mentioned here, investing and getting involved in groups, don't forget, the basic citizen right is kind of depicted in one of Larry's slides of the Citizens March, is to be active about and being in contact with your political leaders, I suppose, when they need to hear from us. I mean, besides getting ourselves educated, we need to share what we've learned with our political leaders who are making decisions every day about these things. So when they send you a survey, I suppose we need to remember to fill it out, and to send it back, or to send it back, send them an email on a regular basis, so they know what the priorities are in your mind. I was struck by something that Larry said in his presentation. The highs, I think it was return to the temperatures, the highs are getting higher and the lows are getting lower, and this gulf is creating. and it seems to me that over the period of time when we've been talking about climate change and remediation, the vast gulf between people have even widened. Those who believe that we need to do something have becoming more strident about it, and those that believe we shouldn't do anything to keep your hands off my car are more strident as well. So that gulf has widened as well. Kind of an interesting relationship between the temperatures and people's thinking about what we should do. So I just want to throw that out. Don't forget, contact your local public officials and your national public officials. And I think with that, I will say, come and view the film together. You can also view it online if you will, but it's always more fun to view those films together with a group. And so we hope to see you out there. Larry and Teresa, thank you very much for your efforts today. It was a wonderful presentation, and hope to see you again soon.
Thank you for inviting me. I was
Yes,
happy to
thank
do
you.
this.
Great. Thank you.
Spread the
All
word,
right.
everybody. But,
See you
Hey,
at the
right
movies.
Yep.
right at 1:30. How about that? Thanks everybody for coming out. We really appreciate your
Yeah,
support.
thank you both.
Okay.
All right. Have a good weekend.
Bye.
Mhm. You too.